Dispersion in light. Dispersion of white light. When a white light is passed through a prism, after getting refracted through the two refracting surface of the prism, we get a band of colors. That is, we call that band of colors a spectrum. White light has got its constituent color, constituent colors. That is, white has got 7 colors in it, and it gets separated when it goes through the prism. That is, that 7 colors are violet, indigo, blue, green, yellow, orange and red. It means white light has got VI, blue, green, yellow, orange and red color. These are the constituent colors of white light. So by Cauchy's formula, Cauchy, Cauchy's formula. What Cauchy's formula says, for any material, when a ray of for any refracting material, the refractive index of the material is equal to E plus B by lambda square and higher terms, where A and B are constant. It means we can say refractive index is inversely proportional to lambda square, or refractive index is inversely proportional to 1 by lambda. And deviation produced by a prism is equal to mu minus 1 into A. That is, this is constant. Angular prism for a given prism is constant. 1 is a constant. It means is directly proportional to deviation produced by the prism is directly proportional to the refractive index. So we can say, since D is proportional to mu, it means, hence we can say this. It means the refractive index is directly proportional to deviation produced by the light, and refractive index is inversely proportional to wavelength of the light. Dispersion. When a ray of light is passing through a prism, it is separated into 7 of its constituent colors. That means, you can say when a ray of light passes through a prism, it split into its constituent colors. That is VIBGYOR. We can call it as VIBGYOR. That is violet, indigo, blue, green, yellow, orange and red. After refraction through two refracting surfaces of prism is called dispersion of light. of light. That is, when this is the prism, when a white light, this is incident on, this is phase A, B, C, angle of prism. So when a light ray, that is white light, is incident on the face AB of the prism, this is the path supposed to be by the prism. It means when it is passing, it undergoes refraction in the first phase, then again refraction in the second phase. Then it is converted into seven colors. That is, 7 colors means waveguide. It means the white light is separated into 7 colors. Each color will have its own wavelength and hence refractive index. Each color has got different refractive index. This after refracting goes this way. There are 7 colors. You can call 7 colors. 7 colors. These are the 7 colors. V, I, B, G, Y, O, R. Violet, indigo, blue, green, yellow, orange and red. So these colors, 7 colors, which we call all the 7 colors, band of 7 colors. This band of 7 colors, the band of 7 colors are called spectrum. Spectrum. Since we have already seen by Cauchy's relation that refractive index is inversely proportional to wavelength, refractive index is proportional to deviation, and deviation is given by refractive index -1 into angle of prism. So these are the color. The red will be here and violet will be here. Red, violet, indigo, B, violet, indigo, B, G, Y, 1, 2, 3, 4, 5, 6. So we can skip one color. There is supposed to be 7 colors. We can call it as Y. Y, or we can take it as one more. V, I, B, G, Y, O. 7 colors. It means it undergoes, the white light is split into 7 of its constituent colors. It undergoes refraction on both the faces. And from the Cauchy formula, we said refractive index so and so. Right. Now, a band of colors is observed, and that band of colors is called spectrum. And this is the angle of deviation. This is the angle of deviation of red color. What is angle of deviation? The angle between the refracted ray and the incident ray, the path of incident ray. The angle between the refracted ray and the incident ray is called angle of refraction, angle of deviation. Then this is the angle of deviation for red color, and this is the angle of deviation for violet color. This is the angle of deviation for yellow color. So since the wavelength of red color is greater than violet, that is, violet is the law, this one, this extreme, that extreme is red. That is, we can say wavelength of the red color is greater than wavelength of the violet. It means wavelength and refractive index are inversely proportional. We can see refractive index of red color and refractive index of the violet color is less than, since both are inversely related. And if refractive index and wavelength, refractive index and angle of deviation, both are directly proportional. So we can write angle of deviation of red is less than angle of deviation of violet. As seen from the figure, this is angle of deviation, this is angle of deviation of violet. So angle of deviation of red is less than angle of deviation of the violet color.